All right, what I want to do here is I want to talk through the two different methods for approaching this problem. I'll go through both of them. As I said, you can choose whichever one works for you. Okay, the first, most students historically prefer the first method, the one where you combine the numerator as a single fraction, combine the denominator as a single fraction. And so I'm going to start with that one. And so if that's the case, you're thinking of the numerator and denominator separately, and you're going to rewrite each of them as a single fraction. So in this numerator, you have a denominator factor of x and a, so that's our LCD factor, x times a. So you're going to take the numerator of your first fraction, 1, and you're going to multiply by the missing LCD factor from this denominator. It has the x, it's missing the a, minus the next fraction's numerator, 1, times the LCD factor that's missing from its denominator. It has the a, it's missing the x. So simplifying that, you wind up with a minus x all over xa. Okay, now we do the same thing in the denominator. Well, the denominator is already written as a single fraction, so we don't even have to separate it at all. X minus a over 1 is left alone. So all we need to do now, instead of dividing, we can multiply by the reciprocal. So the 1 gets moved to the numerator, the x minus a gets moved to the denominator. Okay, and then the final step here is to simplify this, convert it into multiplication. Okay, as we multiply across here, a minus x times 1, I am going to reverse the order of these terms. At the same time, I'm going to factor out a negative, so it's consistent with what I asked. Always write your x's first. So factoring a negative out of the a becomes a negative from the negative x becomes a positive x. Multiply across the denominator. I have x times a times x minus a. And so now you can see, simplifying the fraction, the common factors x minus a cancel, leaving your overall answer to be negative 1 over xa. And the final step is to identify the domain restrictions. So when you're looking at the values that got canceled from the denominator, what do you see? The x cannot be, x can't equal a. Now, anytime you invert and multiply, you have to consider every single factor involved in the fraction that you invert and multiply. No factor of that fraction can ever be a 0. So here x can't be an a, which is shown in our restriction here. So there's no additional restrictions but that one. All right, now there's another method that you could use for solving this, and I'll go through that here, and that's to use the LCD of everything. Okay. Whichever way I choose to use or to set this up, I'm kind of starting it the same way. I block off my numerator from my denominator, but now instead of working individually in those, I'm going to multiply everything by the LCD of all the fractions involved. So looking at this, I need a factor of x, I need a factor of a, and a factor of 1. So my LCD is x times a. Write that over itself. Once you get to that step, now you can work just in the numerator. So I'm going to distribute that xa, that LCD factor. So multiplying through, my x's cancel. I get 1 times the remaining factor a. Minus here, my a's cancel. Negative 1 times an x leaves me with a negative x. So I've converted my fraction in the numerator into one single expression. Do the same thing in my denominator. Just multiply through. So I have xa times x minus a. Again, there's nothing that combines or simplifies there. I can simply leave it as factors. So the final step would be to convert this numerator into the same form of the factors. So take out a negative. The a becomes a, negative x becomes a positive, and then cancel any common factors. And you wind up with the exact same thing. Negative 1 over x times a. And then, again, you do need to go back in, identify any domain restrictions. These actually show that they cancel out. You do need to check all the other restrictions possible throughout the problem itself. You see that x can't equal 0, a can't equal 0. Both of those are shown in the simplified form.